Hi everyone. In this video we're going to cover HSRP. We're going to go over how it works and then how do you configure it. HSRP, it works in an active-passive setup. So you're going to require two devices and one device is going to be active, the other device will be passive. If you add a third device to HSRP, HSRP will kick out the device with the lowest priority. In priority, that value is what elects the active router for a particular VLAN. So every VLAN can have its own active and passive routers. Now, one thing that HSRP requires is a layer 2 connection. In this network, we have this working already. I have IP addresses on these interfaces, go into this core, and OSPF is working. Let's check that out real quick. So here's the interface going to the core, and here's OSPF. I have my networks already pre-programmed in there. Show IP route. I can see this is off the core, and here's my network going to HQR2. If I try to ping HQR2, I can ping it. So this path right here works just fine. And this right here, gig00, that's my uplink to the core. On HQR2, gig02 is my uplink to the core. Now HSRP is kind of a layer 2.5 protocol. It does layer 3 things, but it requires a layer 2 connection. So even though we have OSPF connecting up the core to the HQ routers, and I can ping between the HQ routers, HSRP requires a layer 2 connection. It will not use those layer 3 connections. So I need to make sure I have this connection going across. So that involves the connection from HQR1 to the switches. The switches have to be connected, and then the HQR2 has to be connected to the switches. So let's get that configured. Now on the switches, I have the interfaces already configured. It just has trunks. So this is going to the other switch, it's just a trunk. Then here's the interface going to the router, a native VLAN of 77, and then just a regular trunk. And this right here, port 24, that goes to the end device, that goes to the computer on VLAN 10. So first thing is we go to our interface that has the connection, that's gig01. No shut, we turn it on. No shut, there we go. Now we create the subinterface, int gig01.10. That dot specifies the subinterface. So now we just got to set up the regular interface, IP address 102.16.10.2. So I'm going to assign the HQR1 router the second usable, and the HQR3 router the third usable. 255.255.255.0. Oh, can't do it because I got to set my encapsulation. So I have my subinterface with the IP address on it, and it's going to pick up anything for VLAN 10. Now I have to configure HSRP. So the commands for HSRP are standby, and then the group ID. So I like to use whatever VLAN ID and kind of go along with the group ID. So if it's VLAN 10, it's going to be group ID 10. And I just do that for organizational purposes and making it easy to troubleshoot things. Now, we have our group number. We have put in our IP address. Now, this is the IP address that the end devices will use as their gateway. And this is a virtual IP address, a VIP. And we'll have that be our .1. Now, this virtual IP address is shared between HQR1 and HQR2. So whoever's active will claim that IP address. But as soon as they are no longer active, the other device will take over ownership of that IP address. Standby 10 again. This time we're going to do preempt. Oh, you see right here, the standby group, the HSRP group, went from standby to active. So now this is the active router for that VLAN. So preempt, that's the next command we're going to do. It's going to overthrow lower priority active routers. So what that means is that if your priority number is higher than the other router, you will immediately take back the active status. Standby 10 preempt. Next command, we're going to do priority. So we're going to set router 1 to be the priority for VLAN 10, but secondary for VLAN 20. Priority, and by default, your priority level is 100. So we're going to set it something to be higher because the default will not show in the running config. So we're going to set it at 110. And then last but not least, track. And just as a note, do you see how I'm typing out standby 10 on every single command? That's because if you do not type in the standby and then the group ID, those commands will go into a default of standby group 0. And that means that you're going to have two different groups on the same interface, and the primary group that you want, group 10, is not going to have all the correct configurations and things will not work correctly. So you have to make sure that you have every command that has to do with HSRP has to be in the same group number. Track. We're going to track our uplink to the core router. And what that does is if that link goes down, so if this link between HQR1 and the core router goes down, we want to fail over to our secondary router. That way, this connection is hopefully still up and everything will still work. Now, the reason why we track the uplink is because if this link right here goes down, well, we can't really do anything about it. It's down. This router cannot communicate with that switch, and it cannot communicate with the other router. But if we are not tracking and this link goes down, this router will keep the active status, and all your packets will just die. They'll just get dropped because there's nowhere to send them. So that is why we want to track, so that way we can fail over to a router that still has a path to the internet. Take a look at our interface. Everything looks fantastic. Now let's go ahead and configure HSRP for VLAN 20. Once again, same commands. That'll be the second IP address again, 20.2. Now my HSRP configurations, standby 20. So I'm using a different group ID to go along with my VLAN ID. That way things stay organized and it's easy to troubleshoot. IP address, that's for my VIP. That's the IP address that's going to be shared. I'm going to have that be the .1. This is the IP address that we're going to use as our gateway for the end devices. Preempt. Priority, we're going to have this one be 105. Now, the reason why we're going to pick 105 is because by default, the priority levels will decrement by 10 whenever you have a failover. So since we're tracking an interface, if the interface goes down, the priority will be subtracted by 10. So that means that the priority will be 100. And so we want our secondary router to be within 9 numbers of each other. And we can see that it is now active. And that is okay because we have not configured the other side yet. So now we want to do tracking. Once again, tracking the same interface. I want to make sure no shut and do show run. All right, so our main interface, the actual physical interface, it has no configurations on it, but it is enabled. Our sub-interfaces have down queue with our VLAN, an IP address. Now I'm using the second usable IP address for the actual interface on the router. The VIP will be the .1, priority 110 for VLAN 10, preempt so that it'll take over the active status if it has a higher priority, and tracking the upstream link to the core router. That way, if there's a link goes down, the routers will fail over to hopefully a router that has an active link going out. Now for VLAN 20, it's the same thing. Tagging VLAN 20, using the VLAN 20 network, and using the second usable. Here's the VIP, priority 105, because this is going to be the secondary. This is going to be the passive router for VLAN 20. Preempt, and then once again, track. We're tracking the same interface. So let's just see if I can ping my end devices. All right. I can ping both end devices. So right now, those end devices are going to use router 1 as the primary router. Let's get router 2 configured. Same thing. Oops. Now this time, we're going to use the third usable IP address. You have to make sure that you do not have an overlap of IP addresses. Standby group 10, IP. Then we go through the same process. Preempt, priority 105, and then we want to track. Gig 02 this time. Do the same thing for VLAN 20. Standby 20. IP address 20.1. Preempt, priority of 110. And track gig 02. Do show run. Now we are going to have to do some cleanup. So we have our priority, our preempt, and our track. Priority, preempt, and track, all standby group 10, all standby group 20. .3 looks good. So what we have to clean up is this right here. I'm gonna have to go through and make sure that these two interfaces are not participating in OSPF. In fact, I'll just copy this and paste it in. Now, the reason why we don't want to have that in there is because for whatever reason, Packet Tracer puts it in there by default. On other equipment, on real-life equipment, it doesn't do that. But we do not want OSPF to be advertised to our end devices, and these two sub-interfaces are my end device networks, and so I don't want OSPF there. So that is my HSRP configuration. Let's see my show standby brief. I am standby for VLAN 10. This right here is the active router, router 1. I am active for VLAN 20. And here's my standby IP address, and that is for the router 1 once again. Here's my virtual IP address. I'm going to go over here, router OSPF 10, and then see if I can just paste it. Yay! Clean that up so that way OSPF is nice and clean. There we go, it's nice and clean. Show standby brief. It's active for VLAN 10, standby for VLAN 20. So this computer should be able to ping 10.1 and of course 20.1. Of course, it took a little bit so that way ARP could work, because it has to go to the other router to find it. So now we're going to do a ping to 1.1.11. This is the loopback on the core. Now, as we do a ping, I'm going to actually shut down an interface. We'll see how that works. What if I can do -T? Nope. So this is going to use HQR1 to access the core router. But let's shut it down. So right now, this link is down. So HSRP should fail lower so that way both VLANs are now running through HQR2. You can see how it went from standby to active. And you can see we're both active. This computer can still access the core. Now, from an end user perspective, if I could run a constant ping, you would have saw maybe a little slight delay of a few milliseconds, but HSRP works really fast. You just have to make sure that you have a layer 2 connectivity for all VLANs going across. And so your configurations are going to be almost identical. The only difference is going to be your IP address. Right here. This is the only thing that's different, along with your standby and your priority. So one device is going to have a higher priority. One device is going to have a lower IP address, a .2 and a .3, for example, but it can be any IP address that you want. The main thing is you want to make sure that you don't have the same IP address, and you don't want to use the virtual IP address as your physical IP address. You want to make sure that this right here is not assigned to any physical interface, and that includes sub-interfaces. So that is HSRP. Once again, it's a layer 2.5, 2.5 protocol. It requires a layer 2 connectivity for every single VLAN that has HSRP configured on it between these two routers. In our case, it's VLANs 10 and 20.